welcome back. Today we have 435 non-overlapping intervals. It says here, given an array of intervals, where each interval represents the start and end of that range, we are to return the minimum number of intervals to remove to make the remaining intervals non-overlapping. If we take the first example here, we can actually visualize it here. We have these values and we can see that 1, 3 is the one that is overlapping, and these three are non-overlapping. And we can actually find this easily just by first sorting. We sort by the end ranges. Sort by the ends. That would be these values, like that. And then, after we sort these by the ends, we can check if the next start is overlapping with the previous end. Because if the next start over previous end. So if the next start, let's say this guy. So see here we're sorted. If this is before this, then we know that it's overlapping. In this case, please check out fine. 2 does not come before 2, so this is fine. Does 3 come before 3? It does not. There's no overlap. However, does 1 come before, well, any of these? It does. Then this is our overlap. So to do this, let's say one more time, we have this value and we can say, okay, here we go. We have this value, we're gonna first sort it. Once we sort by the ends, 2 is the smallest, 3 is the next smallest, 4 should come last. So let's move this guy to the last. And now this is sorted by the ends. And once we have that, we can say, okay, let's initialize the end to be 2, because this is guaranteed to be the smallest. And we can have a count that tracks how many are overlapping, and therefore how many needs to be removed, such that the remainder is not overlapping. So we skip this guy because we're starting here and it can't overlap with itself. So we move on. We check. Does the start of the next interval overlap with the end of the previous interval? It does not. Great. So let's update the end to be the new end. So end is now 3. Okay? Our count remains the same. Now, here, does the start of the next interval overlap with the end of the previous interval? In this case, it does. So let's update our count to 1. Okay, and then this remains the same. All right, and now, does the start of the final interval overlap with the end of the previous interval? There is no overlap, so this updates to 4. And if there were further intervals here, the start of that next interval would be compared with the end of the previous interval, which would be this. And this is our answer. All right. And in the case of this guy, we have, here we go. Okay, so these are already sorted by the ends because they're essentially the same. And we go through the same process where the end is the first guy, which is 2. The end is 2. And the count is 0. That's where we initialize things. So we covered the first guy, that's one we're starting with. And we check, okay, for each one after. Does the start overlap with the end of the previous guy? It does. So let's add the 1. And then, does the start of the next interval overlap with the previous guy? It does again. So we add another. And this one is 2. Like so. Just for being thorough, let's handle the last one as well. Let's say we have our input. And this is also already sorted by the ends. 2 comes before 3. All right. And we initialize our n to be the n, the first n, which is guaranteed to be the smallest within this array. And count is initialized as 0. Okay. And the first one we already covered. Now, does the next start overlap with the end of the previous guy? It does not. So this one is 0. This one was 1. 1, 2, 0. 1, 2, 0. All right. So if we translate this into code, let's see. What we did was we initialized the end. Well, we first sorted. Sorting is important. Let's do that first. So given the intervals, let's sort it based on lambda x based on the ends, which is at index 1. So this was sorted by the ends ascending. And then we have some n, which will be the first n, which will be guaranteed to be the smallest of all the intervals at this point because we're sorting it. So intervals at 0, 1, which stores the end, that'll be our first end. And let's say we're counting and we start our count at 0. Okay. So for I in range, and we want to start at the first one because we're not counting the very first one. And we want to start from the second one because the first one is the one that we're comparing against. And then length of intervals. We say if there is an overlap. So if the intervals if the current interval start is less than the previous end, then there is an overlap and we increment our counts. We can call that res actually. Okay. Otherwise, it means that the previous or the current start does not overlap with the previous end. Then we don't increment, we just update the ends. So let's do that and say end is going to be intervals, current interval 1, which holds the end, and in the end we can return the result. And submit. And there you have it. This was, once again, 435 non-overlapping intervals. The time is n log n because we are sorting. And then the space should be, let's see, space should be, we're sorting these in place. We're having some variables to hold constants, so space is O of 1. Thank you. Happy coding. See you next time.